Hello and welcome to another screencast where this time I'll be discussing homeostasis. And so by the end of this you should be able to describe here what homeostasis is, describe also what we mean by negative feedback, and we'll also add in here positive feedback just to kind of clarify or to actually compare and contrast the two, so negative and positive feedback, and also be able to explain the importance of homeostasis, why this is a sort of a big deal in terms of physiology or understanding of physiology, and then explain the role of negative feedback in maintaining homeostasis. Right, so homeostasis, first and foremost up here, describes the body's ability to maintain relatively stable conditions despite continuously changing external and internal conditions. So again, this homeostasis here, if you look up the roots of this homeo and stasis here, is the idea that the body is going to maintain sort of a steady state here. And not that it's going to be exactly the same the entire time, but if we look at this graph, this kind of is a good visual image of what's going on here. So over time, right, and if the internal or external environmental conditions are changing, then the internal conditions of whatever we're measuring here, the body's ability to keep whatever it is here constant, right? So this would be something, say, like body temperature. Right? So our bodies are maintained at about 37 degrees C, right? So 37 degrees C, if we put that right here, we'll notice that our body temperature, the average body temperature is 37 C, but that temperature will fluctuate, right? It's going to go up and down and follow the sine wave, this sine curve, okay? And so whether this is over time, right, so during different times of the day our body temperature will change, and also based on our levels of activity body temperature could change. So whatever it is that we're measuring over here, whatever condition that we're measuring goes on this y-axis, and then over time then we want to know sort of the fluctuations of that. So we will have sort of a maximum and we will have a minimum. So there's the minimum and there's a maximum. And then there is usually some sort of upper set point and some sort of lower set point or threshold that once you go above that or below that, then something will happen to bring the body back into line there. Okay, so if we were to take the average of this, so if this was, say, 37.5 and this would be 36.5, then the average temperature is going to be 37 degrees there. Right, so how does the body kind of quote-unquote know, this is always a big question, right? How does the body know when to bring the body temperature up or bring the body temperature back down or whatever other variable that we're talking about? Well, negative feedback is the mechanism used by the body to maintain homeostasis. So this negative feedback mechanism describes how this is happening. Okay, so in this case we're talking not about body temperature, but we're going to be talking, say, here about blood pressure, right? So this would be blood pressure on the side here, and then we'd have time over here. And so the negative feedback, what's happening is if we start at this point right here, right, and we've identified for ourselves here on the graph, like this is the upper limit, and then here would be the lower limit in terms of the blood pressure. So if the body's blood pressure was to increase here and it goes beyond this set point or above this threshold, then you see here that there will be receptors in the blood vessels that monitor the blood pressure. The control center of the brain responds to an increase in that blood pressure. So there are receptors that are going to detect this. Now we'll talk more specifically about what the actual receptors are, but in general you have chemoreceptors. In this case you're going to have pressure or baroreceptors. There are also temperature receptors, right, etc. So these receptors are monitoring this. They're going to detect that change above this set point. Then they're going to send a signal, right, to the body here, and in order to get the blood pressure down, in this case, the heart rate is going to decrease, resulting in a decrease of the blood pressure. And you notice that here then that blood pressure is ticking back down and maintaining within this normal range right here. So this is a homeostatic balance. Right? If the blood pressure dropped too low beyond a lower set point here, look, we have receptors again, chemoreceptors, baroreceptors, or pressure receptors that monitor that blood pressure change. Sends a signal to the brain. The brain then sends signals to the heart to increase the heart rate, and therefore increasing the blood pressure. And you notice here then that the blood pressure comes back up and is then maintained within this normal range right here. So blood pressure homeostasis maintained. Now, this is a negative feedback. The negative part of this is that you are staying away from the lower limit, you're staying away from the upper limit, right? So if this is the upper threshold or the upper limit, and then this was the lower limit or the lower threshold, right? It's negative because as you approach the lower or as you approach the upper limit, the response is going to be to go away from that upper limit or away from that lower limit back to the middle here, right? And so that's why it's negative, right? You're getting or one way you can think of it as why it's negative is you're going away from. You don't want to stay above that upper limit or below that lower limit, right? So this is negative feedback mechanism. It might be a good idea here to pause and summarize what you've heard so far. Right, so let's contrast the negative feedback mechanism here with a positive feedback mechanism. And the positive feedback mechanism does not result in a maintenance of homeostasis, does not help bring the whatever variable you're dealing with over here back into the range again. So we identify for ourselves, here's the upper limit, here's the lower limit or threshold. And in the case of a positive feedback, what happens is when you reach this upper limit, the body will respond by continuing to do something that will continue that increase up above the normal range. So constantly increasing outside of the normal range. So you reach this upper limit and you don't go back down, you don't stay away from it, you actually go beyond it in the same direction. The same thing is also true down here. So if whatever you're measuring reaches the lower limit, right, you have this decreasing value outside the normal range, and again this continues out here. So notice that homeostasis is not maintained because your values are above the upper limit and below the lower limit. Right? Ultimately, if you stay up here for too long, then this can cause death, which is not a good situation. If you stay down here for too long, then that will also lead to death of the organism. So ultimately, if you want to live, even if you have this positive feedback mechanism, it will have to be this decreasing limit, this decreasing values right here would have to be brought back up into a normal range if you wanted to live. Okay. There are very few examples of positive feedback mechanisms. I encourage you to kind of take a look for those, and we can discuss some of those in class as well. Okay. So negative feedback mechanisms, again, are the ones that maintain homeostasis. This is from your text, and so what we see here, just a visual of what's happening here. So this is our variable in homeostasis. We notice that everything is kind of balanced here, but if we have an imbalance, that is we are approaching the upper level, something is becoming too elevated. That stimulus will then stimulate receptors, so we have receptors that detect that approaching the upper limit. The control center or the nervous system is alerted. The control center then sends signals out to some sort of effector organ, and this effector organ, like a muscle or a gland, will do something in order to bring that value back down into balance. And then the opposite is also true. If you go too low away from this normal range here, then again, we're going to have a receptor that's going to detect that lower level, send signals to the nervous system, which then sends signals to some sort of effector, which then will do something in order to produce the levels to come back up again. Right? So we'll see this teeter-totter example quite a bit in your text this year. Here's one specific example, again going back to the body temperature example. So homeostasis, normal body temperature, here is the range, right? And so any of these body temperatures are considered to be normal, right? However, if your body temperature increases, right, increased body temperature, for example, when exercising or that it's too hot outside, right, then your hypothalamus here, so this body, the body's going to detect this. The hypothalamus in the brain is the sort of temperature regulation control center that will detect the increased body temperature, then send signals to your blood vessels to dilate, and when the blood vessels dilate, that brings blood to the surface of your skin and you get flushed, you turn pinkish red, and that increased blood going to the surface, you have heat evaporating away from the surface of your skin. Your hypothalamus also, via the nervous system, will signal your sweat glands to begin producing sweat, and as the sweat leaves, water has a high specific heat, so it holds a lot of heat, and so as you lose the water, you lose some of that body temperature. So these two reactions here then serve to bring the body temperature back down into this homeostatic range. On the flip side, if your body temperature is too cold, right, due to cold environmental temperatures, right, then your hypothalamus detects that, will send signals to your blood vessels to constrict, to keep blood away from the surface of your skin, and shunt that blood to your core, so it remains to your heart, your lungs, your other body organs, your brain, continue to work within this normal range. And then also your nervous system will also signal your skeletal muscles to begin to contract rapidly, which causes shivering, and that actually generates some body heat as well. So that both of those mechanisms there, both of those actions, I should say, will then serve to increase the body temperature, bringing that body temperature back up to within that normal range. Right? So again, you should be able to see here that there is the diagram, but then also graphically, if body temperature over here and over time, that body temperature is going to fluctuate like this in a normal range, but if it gets too hot, then something will happen to bring that body temperature back down, and then it fluctuates in that normal range again. And then if something happens that it becomes too low, the body will respond by shivering, and then that body temperature comes back up again. Okay. And again, this being sort of the normal upper limit, lower limit. Right? You go above that, and then it's going to bring it back down. Okay. So another example of blood glucose levels, I can let you look at that on your own. If you're curious about insulin and glucagon and diabetes, here's an example of that. But again, normal blood sugar levels are maintained by negative feedback mechanisms. So you should be able to describe here in general what we mean by homeostasis, and then a negative feedback mechanism, and kind of compare that to the positive feedback mechanism as well. Explaining the importance of homeostasis in maintaining organisms, and then the role of negative feedback in maintaining that homeostasis. Okay, thanks for listening. Bring your questions to class.